So now that we have an understanding of how markets work when buyers and sellers have different information, let's apply that to a couple of interesting and important real-world examples. We'll, of course, do simplified examples of these real-world markets, but we want to capture the important features. Let's start with the market for health insurance, where we're going to show that just like with the market for used cars, the market for health insurance can fail because of this different information. In this case, we're going to suppose it's the buyers who know more about what's being traded than the sellers do. Exactly the opposite of what we did with used cars, where the sellers knew the value of their car. The idea here is that someone who's contemplating buying health insurance probably knows more about how risky they are to insure than an insurance company does. And insurance companies, of course, try to mitigate this difference in information by placing buyers into risk groups, perhaps based on age. But even within any group, the buyers in that group are going to know more about how risky they are than the insurance companies could possibly know. So we want to ask is, can we get a market for lemons effect in the market for health insurance? And the answer is, of course, going to be yes. Let's think about a simple example of this where people can either be low risk or high risk, and the buyers know and the sellers don't. So let's suppose a low risk buyer thinks that health insurance is worth 6. And a high-risk buyer thinks it's worth 12. It's worth more to high-risk buyers than low-risk buyers because they're more likely to collect on the insurance. Insurers know how costly it would be to insure any buyer if they knew whether they were a low or high-risk buyer, but they might not know which is which. Let's suppose that the cost to insure a low-risk buyer is 4 and the cost to insure a high-risk buyer is 10. And let's further suppose that half the population falls into each group. First thing to notice here, of course, is that if insurers could tell which buyer was which, and if they were allowed to charge different prices for different riskiness of buyers, then everyone would get insurance. Low-risk buyers would pay a price somewhere between 4 and 6. High-risk buyers would pay a price somewhere between 10 and 12, and everybody would be insured. High-risk buyers, of course, aren't really happy with this because they're paying a high price, but if they're going to be insured, they have to pay a high price if insurers can tell who they are, because they're actually costly to insure. But now let's suppose that insurers can't tell who's who, or can't charge different prices even if they can tell. Well, then they're simply going to look at how costly is it to insure the randomly selected person. So let's start by supposing that insurance companies think that both low-risk and high-risk buyers buy insurance. If they believe that, then they believe that half the people buying insurance are low risk, half are high risk. So the expected cost of insuring someone is going to be half of 4 plus half of 10, and that's 7. That's what it costs to insure people. So that's the least insurance companies are going to charge for insurance. But notice that that's more than insurance is worth to a low-risk buyer. The low-risk buyers think it's only worth 6. So they're not going to buy insurance at that price. That means that there is no equilibrium in this market in which everyone gets insured. At least the low-risk buyers are not going to buy insurance. In my little example, that's half the population. The problem is insurance is just too expensive for them. It's not their fault. It's not the insurer's fault. It's simply the expected cost of insuring the randomly selected person. Now, in this little example, there actually is a market for high-risk insurance. Right? We know that anyone who wants to buy insurance here must be high risk. And insurers are happy to insure them at a cost to the insurers of 10 and a price somewhere between 10 and 12. So the market hasn't completely collapsed, but half the population is not buying insurance. You could also imagine taking this market and expanding it to more and more types, just as we did with the market for lemons in our used car example. And depending on the values you put in, you can get the market to actually completely collapse so that only the very highest risk people ever buy insurance. That's what we mean by this market for insurance possibly simply disappearing. Now, let's back up for a moment and suppose that somehow insurers could tell which type was which. Perhaps someone's devised a test that will perfectly identify low-risk and high-risk buyers. Well, then, if insurance companies use that test, and if they're allowed to charge different prices, then everybody gets insured again. Low-risk buyers get insured for a low price, high-risk buyers get insured for a high price. But it requires some ability to distinguish who is who in order for that to happen. Same kind of phenomena happens in the market for workers. So let's think about job applicants and potential employers. Job applicants probably know more about how productive they're going to be on the job than the employers do. And just like insurers, firms try to sort out who's going to be productive and who's not, but they're never going to be perfect at it. So we're going to get exactly the same kind of phenomena we got in the market for insurance or in the market for used cars. You can easily have this market have problems where not everybody enters and is employed, even if in a world with perfect information, everybody would have been employed. Just like we saw in the market for used cars, of course, the people who have information about their type have an incentive to try to provide it. And in the market for workers, that's particularly interesting because one way you can provide information is through education. Suppose that it's cheaper and easier for someone who would be highly productive to get a diploma. Well, then actually education can serve as a signal, because if it's cheaper for a high productive person to get a diploma than it would be for a low productive person, when the high productive person gets the diploma, they pay less for it. They can use that to signal that they in fact have high productivity. They're identified now as a high productivity type and they earn higher wages. And notice that nothing in that story that I just talked about said anything about whether the education and getting a diploma had any direct effect on productivity. The diploma has a value even if it has nothing to do with job skills, even if it doesn't produce any direct benefit for productivity. It has a value simply because it provides a signal. If in addition the education produces job skills, it has an additional value on top of that signaling value. This is what Michael Spence noticed, and he actually shared the 2001 Nobel Prize for his work on education serving as a signal. One of the things he pointed out is exactly what we just said. Education can be valuable even if it does not increase someone's productivity just because of its signal value. And in fact, that phenomenon is really much more general than just education. If you think back to the market for used cars, warranties on used cars, or simply having sellers say this is a guaranteed or certified used car, can have a surprisingly high value, more than the direct effect of the warranty. That is, more than the warranty is actually worth to a buyer, because the warranty can also serve as a signal. So we get the signaling phenomena in markets where people have different information as they try to sort themselves out.